Welcome back to Crops TV. I'm Billy Beck, Extension Forestry Specialist, and we're going to talk about streambank erosion. It impacts all Iowans, so let's dive in. So the plan for today, I want to go over the impacts of streambank erosion, impacts landowners and all Iowans, and I really want to dive into the drivers and mechanics of streambank erosion. So why is this happening? Then we'll hit solutions, both from a site and watershed perspective. And then we'll go into some resources if you want to learn more. So streambank erosion impacts. If you've got a stream running through your property in Iowa, you're probably dealing with some degree of streambank erosion. For landowners, it comes down to lost ground, threatened infrastructure, and it's just obviously very unsightly looking. For all Iowans, streambank erosion has potential to deliver sediment and phosphorus to our waterways. Sediment in excess can degrade aquatic habitat, and phosphorus in excess can be associated with harmful algal blooms. And also, we've all seen streambanks threatening infrastructure, roads, bridges, and other things. So it impacts everyone, not just Iowa landowners. If you look into the science, streambanks contribute 31% of Iowa's riverine total phosphorus export. That's from a study by Keith Schilling and others out in 2021. And if you look around the U.S., Midwest, and the South, a range of studies have shown that streambanks contribute 25 up to 96% of the sediment exiting watersheds in those areas. So 25 to 96% of sediment loads in these areas are coming from streambank erosion. So I really want to hit this. Streambank erosion is natural. It's an important process in stream systems. This is a really cool map in a series of maps by Harold Fisk out of the 40s. This is the current Mississippi River channel in 1940s. But those are the historic Mississippi River channels in the color you see around it. So my point here is these rivers move. It's natural for rivers to move. It's natural for streambanks to erode. Even in the middle of Iowa, going away from the Mississippi, this is the Skunk River in central Iowa. You can see the current river there with the yellow arrow, and you can see historic meander scars on the right with the red arrows. So again, even the Skunk River historically moved around quite a bit, and that's natural. In properly functioning systems with streambank erosion, sediment leaving the eroding bank would be mostly deposited on the point bar immediately downstream. So again, that's in properly functioning systems. However, most of our systems in the Midwest and honestly globally are not properly functioning, and we'll get into that in a second. So if streambank erosion is natural, what's the big deal? Well, the big deal is accelerated streambank erosion is the real issue, and that's caused by a range of factors that we'll hit in just a second. So it's natural, but it can be accelerated, and that's where the issues occur. All right, this is a really cool image that kind of sums up the drivers of streambank erosion in a nutshell. This image is based on Lane's balance. It's a really cool image. I love to study it and look at it. That's what I do on my weekends off. So we've got two sides here. And if you think about streams transport their sediment and their water with no net degradation or aggradation. When that occurs, we call that stream imbalance, or a fancier term is a dynamic equilibrium. So they're carrying their water, they're carrying their sediment. We don't see widespread erosion. We don't see widespread deposition. So now look at the figure here. On the right, we've got the water. On the left, we've got the sediment. So what happens if we start messing with one of those two, and what happens to the system? So let's just take water, for example. If we keep filling that pitcher up with water and add weight in the figure, that's going to tip the scale towards degradation, because a lot more water means a lot more power in the channel to move sediment and erode the bed and banks. On the flip side, if we add more sediment, we're going to see the scale tip towards degradation, because the flow of the water simply can't carry the new volume of sediment. So when we mess with one side of the scale and don't address the other, that's where the problems occur. So I, in my brain, like to think of these sides as the water side, the ability to erode the stream bank, and on the sediment side is the ability to resist erosion. So they're fighting out there in battle. We want a balance, but sometimes it gets off balance. So the ability to resist, those are factors such as the sediment load, the sediment size coming through the channel, the bed and bank material, riparian vegetation cover, in-channel wood, beaver dams, and stream floodplain connectivity. So those are the factors that drive the resistance to erosion. The ability to erode is driven by the stream discharge, which is basically the rate of and volume of water pumping through that channel, often spelled out in cubic meters per second. And also the stream slope. You can imagine a very, very high slope versus a low slope and the power of erosion that is associated with each. So, lanes balance, print this out and stick it on your refrigerator. It's a good thing to really get familiar with. Okay, so what have we done on the landscape of Iowa, and honestly across the globe in many situations, to offset that balance? So here are some impacts of landscape and hydrological alterations on that balance, and really it's why we're seeing this accelerated erosion in our watersheds. So let's think about the ability to resist, those factors that we talked about on the previous slide. So what have we done in general on the landscape for the last 250 years? Well, we've removed a lot of riparian vegetation, we've removed a lot of in-stream wood, and we've reduced sediment delivery, which is actually a good thing. We've reduced, through no-till and edge-of-field practices, we've reduced sediment coming off the uplands and into the channel. However, if you don't balance that with adjusting the hydrology, the stream's going to want to pick up sediment elsewhere. It's very hungry. So where do you think it's going to pick it up? Correct, the channel. So let's talk about the ability to erode. What have we done there? Well, we've converted land from prairie and woodland, which have incredible infiltration rates, or like a sponge, ability to soak up rainwater and deliver it slowly to the channel. So we've decreased that. We've converted to row crop, we've got urban areas, we've got parking lots. So we get a lot more flow hitting the surface of the earth and going directly into our waterways. We've also straightened the streams. As you can see there on that figure on the right, from central Iowa, the red channel is the current channel, and the green channel is the channel in 1930. So the green channel, with more distance over the valley length, has a much lower slope than the red channel. And you can imagine the stream velocity and stream power impacts that would have. The last thing that we've done is subsurface drainage. We've drained a lot of our landscape, again, increasing flow. So if you think about lanes balance in that scale, we've really heightened the ability to erode, while at the same time lowered the ability to resist in our channels. So we're seeing an excess of stream bank erosion. So it's really important here to think about, a lot of times in these unstable systems, it's not a single point issue that is causing erosion, it's a watershed scale issue. All right, moving on to mechanics, the good stuff. Bank material is a big factor in resistance to erosion. And surprisingly, banks are often made up of very different material that's been deposited in the floodplain over thousands of years. This is an example from central Iowa. You can see the layer cake here. All three of those layers have incredibly different resistance, degrees of resistance to erosion. So if you're thinking about how to address stream bank erosion, you really need to know what your banks are made of. Okay, so when we start messing with lanes balance and we get out of balance, these streams respond in a predictable series of adjustments to regain equilibrium. They're trying to get back into equilibrium. So collectively, these adjustments are called the Channel Evolution Model, or CEM. On the right there is a figure adapted from Simon and Hupp, 1986. Basically shows pre-modified where everything's in balance. Then we start messing with the flow or sediment, and this is what generally occurs in our systems. And across the state of Iowa, many, many watersheds are within that stage 3, stage 4 zone there, as you can see in the photo on the other opposite the figure there. So what does that mean? A lot of our channels are down cutting very deeply, or what's called incision. And then at some point, the stream bank walls get so tall they become unstable and they start to collapse and the channel gets wider. So there's a really, really good example there in that picture of stage 3 and stage 4. So that's just characteristic of those two stages where we're at in a lot of watersheds across the state of Iowa. Big, steep banks, big, wide channels. So degradation and widening. Eventually, the channel will form a new floodplain at a lower level and regain equilibrium. Okay, so processes of erosion. Processes can help you determine where you're at in the CEM and kind of what to look forward to in the future and how this channel is going to respond over time. Kind of gives you your bearings of where you're at. And it's also really cool to study scientifically. But we see a lot of mass wasting in stages 3 and 4. So this is giant failures of banks all at once or in giant blocks. Here's a really, I think it's cool. This is a time-lapse video. We were lucky enough to catch a massive mass wasting event in a central Iowa watershed. So you see it just whoop, all goes at once, and you can see there's an old fridge or freezer in the stream. We often say it's not a Midwest stream unless there's some appliance in the waterway there. This is one that a lot of folks don't think about, but research in central Iowa has suggested that this is a very significant contributor of soil from banks into the water column, and it's called subaerial processes. These are processes like wet-dry cycles and freeze-thaw cycles, primarily on unprotected, unvegetated banks like you see right here. And this is very visible in winter and especially on south and west facing banks when we get freezing cold temperatures at night and then we get direct sunlight in the day. That soil shrinks and swells and shrinks and swells, and those aggregates simply pop off into this and accumulate at the stream bank toe there, which have almost no cohesion, and they're easily whisked away by even the most moderate of flow events. So this really speaks to the importance of stream bank and riparian vegetation covering and insulating these banks, protecting them from those temperature extremes. I call this kind of pernicious erosion. It's sneaky. It's not a big massive event like mass wasting, but it really it sneaks up behind you and is a significant contributor. And lastly, we've got the most straightforward one. That's basically fluvial erosion or fluvial processes, right? Being whisked away simply by the force of water grinding on the bank over time. If you think back to that layer cake, all those different layers have various ability to resist erosion, fluvial erosion in that system. You can kind of see a combo here. The subaerial process generated sediment is now being whisked away by the stream flow, and you can see the high water mark there. Okay, so site-based solutions. Now remember, with these site-based solutions, we are stabilizing within an unstable system. You're treating this as a point practice. It's not really going to do anything for the overall health or stability of the watershed. This is obviously a large project, a very, very expensive project on a large river that is kind of out of the grasp of reality for most landowners. However, it's a really cool image that shows the big three of stream bank stabilization. What you're going after no matter what practice you're putting in on the ground. So the top one with those veins up there, those are deflecting flow away from the bank, obviously reducing fluvial erosion. These banks are vegetated, and the floodplain adjacent, which you can't see, is also vegetated to slow down that erosion, prevent things like scour and fluvial erosion, but also subaerial processes as well. And that vegetation is really key because those rock work practices slow the erosion down long enough for vegetation to take hold, and vegetation, perennial vegetation like trees, is really your long-term key to stable stream banks. The last thing they did is they reduced that slope from very, very vertical to about a 3-to-1 or 4-to-1 slope that spreads out, that dissipates the energy of an overbank event over a greater surface, reducing potential for scour. So, site-based solutions are not really a watershed scale approach, but if you've got cropland or an infrastructure of some form being threatened, site-based solutions can work. All right, we're going to go from very, very non-complex to very, very fairly complex here on things to do on your property about stream bank erosion. So at bare minimum, for these site-based solutions, start assessing and monitoring the erosion. See how fast it's moving and where it's occurring. Keep your eyes open for fine exposed roots on the stream banks. Those fine roots are very vulnerable in the environment and they disappear very quickly. So if you see fine roots, you know that's been very recent erosion. And take some photo points. Have somebody standing at the exact same spot year after year and see how much that bank is moving and when. If you want to get a little fancier, you can install rebar or stream bank pins into the bank, come back periodically and measure how much of that pin is exposed. That'll give you a sense of, is it aggrading or degrading, and at what rate laterally throughout the year. Another solution is just to simply back off. You know, we talk about the value of floodplains. Maybe we should back out of them and just let them do their thing. So practices like riparian buffers and livestock management are very effective at just kind of simply backing off and letting the river establish vegetation and kind of do its thing with getting back into equilibrium. Now, one note, you need to have a plan, not just simply backing out of there. In a highly grazed system like this or another highly managed system, if you simply back out and don't have a planting and maintenance plan, you may be encouraging problem species to take hold in that area. So riparian buffers and then livestock, things like restricted access, rock crossing, and alternative water and shelter to encourage the cattle or whatever livestock to spend as least time as possible out of that stream channel and on the stream banks. All right. Moving further along in complexity, tree revetments. These do a lot of things that those rock veins, those very expensive rock veins were intended to do. We've got publications on this. I won't get into the nuts and bolts of installing these, but in a nutshell, these do a lot of things. A, they reduce fluvial erosion by deflecting flow away from the bank. They stabilize that bank toe and help prevent mass wasting. And they also kind of passively work to reduce that bank angle as the bank from above continues to slough off and build up and get trapped within those evergreen canopies that you see right there. So here, these are cut eastern red cedar trees, very, very rot resistant evergreen trees that are anchored to the bank of the stream toe, and intended to slow down erosion long enough where more permanent vegetation can establish above. Again, not to get into details, but they were anchored using earth anchors. This is after one high flow event. You can see the massive amount of deposition already being trapped within those cedar trees, and that's again reducing the slope, adding stability, and it's a great media for new vegetation to start emerging. Okay, willow stakes. Again, not to get into the details for time, we've got publications on this. Cut willows in the dormant season, hammer them into the stream bank, making sure that tip is down at the groundwater level. And those stems they grow roots on the base and leaves on the top. Those roots anchor the bank together, and then you've got the shading of the stream bank, protection from fluvial flow, fluvial erosion, all kinds of good stuff from those live willow stakes. We've got a pub on that as well. All right, getting up in complexity, log veins. Same concept as the other ones, just a little bit more substantial. So again, what these things do is they deflect flow away from the bank, and as you can see here, they encourage sediment deposition between the veins. Again, a great media for new vegetation to take hold. And like I said before, the purpose of these things is to slow erosion down long enough where permanent perennial vegetation can take hold, and that's your key to long-term stability. Lastly, same concept, but root wads flipped and driven into the bank and stabilized there with either rock or cable or posts. One cool thing about these is they provide unique aquatic habitat in addition to working to stabilize your stream bank. All those are great. Those are great point solutions for erosion on your property, but at the watershed scale, if we stabilize all those stream banks and don't address the hydrology alterations or the sediment alterations, we're still going to be stuck with an unstable channel. Restoring our channels to balance is a watershed scale effort. It's going to take a range of practices both in the channel but also in the field and the uplands to restore that balance and get stream bank erosion to a level that's tolerable. So things like perennial vegetation, prairie, tree plantings, especially in the floodplain, functional floodplains, backing out of floodplains and letting them do their thing. They're a great spot for long-term storage of sediment and nutrients. There's a floodplain forest, beautiful floodplain forest there in the photo. In-stream wood, meanders, beaver dams, all those practices, or passive practices I would say, tend to work to slow down that flow and reduce that potential for erosion. And then lastly, but definitely not least, are wetlands. Wetlands are a great sponge to slow down that slow and kind of set that lanes balance back equal. So anything we can do in the uplands or the riparian areas to increase the sponge is a good thing. To learn more, I know you're very chomping at the bit to learn more. But there's a lot out there that I would recommend, and this is just the tip of the iceberg. The Iowa Learning Farms has a series of webinars that are archived. Go to their website, look for archived webinars, and search for topics such as floodplain and stream channel, and you can dive into more of the research aspect of stream bank erosion. We've got 2 Iowa State University Extension publications on our store. Just search for 4411 and 4412. It's a summary of the research that was mentioned very briefly throughout this presentation. Lastly, I encourage you all to attend an ISU extension event in the field or an ISU extension conference around the state of Iowa and also the region. One of those that happens every spring of each year is the Tri-State Forest Stewardship Conference. Information about that is on our website. And then me too. I'm fascinated by stream bank erosion. I love researching it. I love thinking of practical solutions and applying those on the ground for landowners. So please, if you have any follow-up questions, use me as a resource as well. Thanks for watching Crops TV. For Iowa State University Extension Outreach, I'm Billy Beck.